Hello. In this video, we'll see how to design and implement a REST API using Spring Boot. So far, we've been talking about creating MVC web applications. I'm a big fan of MVC. MVC applications are easy to create, easy to maintain, and work well in many situations. The problem is that everything is done on the server. With client devices become more and more powerful, it just makes sense to move some of the processing to the client side. One way to do that is known as AJAX. MVC web application with AJAX is still basically an MVC application. Some pages generated by the application contain some JavaScript code, and this code will send asynchronous requests to the server application to load or save data and to update the page. Someone came up with a name for this technique and called it Asynchronous JavaScript and XML, or AJAX. And then later, some people took the idea of AJAX to the extreme. Now, the whole application has only one page. All the UI changes, all the user interaction, all the communication with the server is done entirely using JavaScript on this one page. This is known as single-page applications. These applications are usually built with frameworks like React and Angular, which you'll probably have heard of. Now, from a server-side application perspective, this is great because the server application no longer needs to generate web pages. This makes the server-side application more efficient and scalable, and also, importantly, allows us to use the same server-side application to serve many different types of clients. So now the server-side application becomes something we call a web API. It's basically a web application that provides data and functions for other applications. The web API in a system is often referred to as the backend of the system. And the front end can be all kinds of applications. It can be a SPA or a mobile phone app or a web application communicating with the server via some AJAX operations or even a desktop application. This setup is particularly good if you have something that you want to run on different platforms. The front-end apps usually need to be developed specifically for a platform. For example, you may need to have a Windows version, an Android version, an iOS version, and so on. And they all need to be developed separately. But all of them can use the same backend web API. These days, there are mainly two types of web APIs. Here we refer to web APIs. The web APIs we talk about are server-side web APIs. Occasionally, you'll see people calling some JavaScript APIs web APIs, but those are client-side, essentially JavaScript APIs. And in this lecture, when we talk about web APIs, they are strictly server-side web APIs. Anyway, currently there are two types of these web APIs called REST API and GraphQL API. REST API, sometimes also called RESTful Web Service or REST Web Service, is fairly easy to create, as we'll see later. It's currently the most commonly used type of web API. GraphQL is a more recent technology. Generally speaking, GraphQL is better than REST, but it's more difficult to create. In this lecture, we'll only talk about REST API. Now, let's start with an example. We'll use the code from the Spring Data JPA example. So in this example, we have an employee class, which we already add the ORM mappings, and we have a project class, and we also have a controller with some handler methods, and so on. And in the database, currently we have 3 employees in the employees table: John, Jen, and Tom. And Jen's supervisor is John, and Tom's supervisor is Jen. And we have some projects. So this is what we have from the last Spring Data JPA example. And now let's add something to create a so-called REST API endpoint, which is basically a REST API function that can be used by other applications. And the one we'll create is something that can return all the employees' information. So since employee information is all in the database, we are going to create an employee repository, just like last time. And let's copy over this code, except that this time we'll do employee, and employee. Okay, so now we have the repository, and let's also create a new controller. It's possible to use the same controller class, but just to make things more clear, I'm going to put all my API implementations in a controller called API controller. And like before, we will annotate this with controller, and then we will create a method, and this method will, let's say, return a list of employees, and the method name again doesn't really matter, we'll call it get employees. In order to get those employees, we'll have to get them from the database, so we'll need the employee repository, employee repo, and we'll do a controller injection, so employee repository, employee repo, and this is something like that. And let's import, and employee employee. Okay, I misspelled. Okay, so now we have these employees, and then we can simply return whatever employees we have, and we'll do a find all. Okay, so notice that find all returns an iterable of employee rather than a list of employee. That's okay, so we'll change this to iterable and import that. Okay, so that's pretty much it. We are almost there. And so notice that normally in a controller, we will return in a handler method, we will return a string, which is a view name. Now, this is a web API. There's no view. We simply return the data itself. Now, this data, however, we want it to be returned inside the body of a response because it's going to be quite some data. So here we'll add a response body response body annotation. So this basically tells the Spring framework that this return value is not a view, and it's data that we want to put inside the body of the HTTP response. And of course, we still need to do the mapping thing. So let's put the mapping here, and I'm going to put it at /API employees. So all my API endpoints will start with /API and then the URL of a particular endpoint /operation. Okay, so that should do the trick. And let's run it. And let's go to localhost 8080 API employees. And voila, it works. And we get the first employee, John. We then get the second employee, Jane, whose supervisor is John. And we get the third employee, Tom, whose supervisor is Jane, whose supervisor is John. So we get all the data. Now, the result is not exactly like what we would typically want, but we'll get to that later. For now, we can see that it indeed works, and it's not too difficult to implement it. There are two things about this example before we move on. The first is that we use two annotations here, controller and response body. And for REST APIs, the vast majority of the time, the data will be returned inside a response body. So Spring provides another annotation, which is basically a combination of controller and response body. So instead of having to do it twice and having to specify response body for every single API controller method, we can simply say REST API here. And so that's the first improvement we can do. And there's another improvement typically we would want is we can put a request mapping on the controller. This way, all the handler methods inside the controller will start with the same prefix in their URL. And this allows us to simply say employees for this one. And the actual URL is still /API/employee, but it makes it clear that everything inside this controller starts with /API, and then each method has a simpler and more clear URL itself. And let's save it and do a refresh to make sure it still works. Yeah, it still works. So the first thing is REST controller, which is basically a combination of controller and response body. And the second thing is notice that here we are returning a Java object, which is the iterable of employee objects. And Spring automatically convert that into a JSON object, which is an array of employee objects. And this process, converting a Java object into JSON or sometimes XML format, is referred to as serialization or marshalling. And from the opposite direction, converting from JSON to Java object, is called deserialization or unmarshalling. We'll see that Spring Framework can do the other direction automatically as well. So this is quite convenient. Otherwise, we will have to do this ourselves because we can't just send Java object directly back to the client. It has to be in a format that can be transferred as part of an HTTP response and can be used by whatever language used by the client. So the return value needs to be serialized into either JSON or sometimes XML, and the input value from the client will need to deserialized into Java object for our server code to use. All right. So as we can see, creating a REST web API is actually not too different from creating a MVC web application. It's basically MVC minus the view part, right? There's no view here, we return data directly. And this actually makes perfect sense because a web API is a web application that provides services to other applications. So it produces data in a format that is easier to use by applications instead of generating web pages for humans to read. Now, with that being said, there are some things that are specific to building REST web APIs. In this lecture, we'll cover a few of them. First, what does REST mean? Then the convention used for designing web API endpoints, the need for data transfer objects or DTOs, and then how to handle errors. So what is REST? Well, the term REST was introduced by Roy Fielding, who is an influential figure in the web community. He was involved in the creation of many specifications related to the web. In his PhD dissertation, he studied network-based software architectures, and REST is the term he used to describe the common characteristics of scalable, maintainable, and efficient distributed software systems. According to Roy Fielding, these systems share 5 common characteristics plus an optional one, and these are known as the REST constraints. The system should have a client and server architecture. It should not maintain internal state because maintaining state is expensive and prevents scaling. It should support caching, of course. The resources in the system should be uniformly accessible, like having URLs or URIs. And the system should have a layered or tiered structure. And optionally, it should support code on demand. Think of code on demand like something like JavaScript. You'll go to a web page, it automatically downloads some JavaScript code, which will then run inside your browser. So why do we call this web APIs REST API? Well, the idea is that we want to mimic the largest REST system, the web. In particular, REST Web API uses URLs to represent resources like objects, uses request methods to represent operations, and most importantly, REST Web API should not keep session data, so it's stateless, meeting an important REST requirement. Now that we know what REST means, let's create a REST API for managing employees. This API will provide 5 operations, or in web API terminology, 5 endpoints. Get all employees, get an employee by ID, add a new employee, update an employee, and delete an employee. Let's first take a closer look at a so-called REST API endpoint. Endpoint represents an operation. To design a web API endpoint, we need to specify what the request looks like and what the response looks like. In this case, for example, the request will be a GET request to the URL /employees/ followed by the ID of the employee we want to get, and the response will contain a JSON object in the response body with properties ID, first name, last name, address, and supervisor ID. If you think about it, designing a REST API endpoint is not too different from designing the API of a function or a method. In both cases, we need to specify an action, the resource the action applies to, the parameters, and what the result looks like, or the result of the format of the result. The easiest part of REST API design is probably deciding the object format. There are really only two options, XML and JSON. So you can choose either or both. If you choose both, you can let clients to select which format they prefer using the accept header in HTTP request. If you are unsure, just choose JSON because it's a more efficient format, and there's a good chance that the client is written in JavaScript, so they can use JSON directly. In our examples, we'll use JSON because A is the preferred format in general, and B is the default format provided by Spring Boot, as we saw in our early example. When it comes to URL pattern of an endpoint, we should follow some design conventions in order to call our API a REST API. Take this as an example. The first URL pattern would be considered a good one for a REST API, while the second one would be considered bad. Although functionally they do exactly the same thing, and in fact, when we write web applications, we will also use URL patterns like the second one. However, remember that we are designing web APIs, not web applications. REST APIs in particular follow certain conventions to make them quote-unquote REST. Here are the 4 important conventions we should follow when we design a REST API. First, use URL to represent resource. Then, use request method to represent action. Use request headers for content type and content negotiation. And use response status code for result status. There are some additional conventions regarding things like idempotency and stuff, which we don't really need to care about, at least for now. Now, let's talk about the first one, using URL to represent resource. Suppose we have an employee class like this with ID, name, supervisor, subordinates, and supervisor and subordinates are also employee types. In a REST API design, we would use /employees to represent all the employee objects. By the way, is why we use the URL here. And if we want to represent one employee with a specific ID, we would want to use /employees/ID. And notice that it's also customary to use URL path segments to represent the structure of the objects. For example, the structure of an object is from employee to name. So if we want to say the name of a certain employee, we would want to say employee/ID/name. And similarly, the supervisor of an employee is employee/ID supervisor. And if we want the supervisor's name, of course, it will be supervisor name. And similarly for subordinates or a specific subordinate of a specific employee. So that's typically how we represent resources using URL and URL patterns. So we can use URLs to represent objects, but it doesn't say what action we want to perform on those objects. This is where we use request methods. Remember, there are quite a few request methods like get, head, post, put, and so on and so forth. Now, when we develop web applications, we mainly just use get and post. But when we develop web APIs, we can see that some of these request methods map nicely to the so-called CRUD operations. Specifically, post maps to create, get maps to read/retrieve, put or patch map to update, and delete, of course, maps to delete. And this is why we use get method here, meaning that we want to get all the employees. So action and objects. Now for update, the difference between put and patch is that if we want to update by providing a full object, we should use the put method. You can think of this as take this object and put it at this URL, or put it at the object represented by this URL. Sometimes our object is large and we may only want to update some properties. It would be inefficient to have to send and process the whole object. In this case, we can send only the properties we want to update, and the appropriate request method to use is patch. You can think of it as using the provided data to patch the object at the specified URL. I should point out that not all operations can be represented nicely by request methods. A good example is a search operation. A search operation can be quite complex. You may want to search by field. For example, you may want to search only the first name of the employees, and then search may involve logical operators. For example, you may want to say search the employees where the first name is John, but the last name is not Doe. There's not a request method for search. The reason is simple. When the HTTP protocol was designed, the designers did not know that the request methods would later be used to represent web API operations. So what do we do? Well, the first thing is to remember that all this stuff is really just conventions, not some hard rules. It's good to follow conventions when it makes sense, but if the convention doesn't cover it, like in the search case, we are free to come up with our own design as long as it's reasonable. For example, for a search endpoint, I would probably just use post with a query object in the request body. Now, with that, let's implement our REST API for managing employees. The first endpoint we already built, which is getting all the employees. Now, it works, but the result looks little bit odd. In particular, we can see that if employee has a supervisor, it will include all the information about the supervisor. And if a supervisor has their own supervisor, then that supervisor is also included, and so on and so forth. So if John has a supervisor, it will be included here. And we can see that this really is a waste of resources, because all the information about John is already included here in the John employee object. That really shouldn't it really shouldn't be included here again and here again. And same for Jane, whose information is already in the result. The fundamental problem here is that we're sending data model objects back to clients. In other words, we are sending employee objects back to the client. And it's clear that the data models designed for storing data may not be the best for other purposes. For example, in this case, the data model employee references a supervisor object, but the client code may not need that, or that information is already part of the result. Another example is a data model class for a user, which may include a field for the user's password, but that field, of course, should never be sent to a client. We can solve this problem with a design pattern called Data Transfer Object, or DTO. It's basically an object that carries data from one part of a system to another part. And in a web API, it can be used to create the objects returned to a client. So let's create our DTO and see how it works. Now I'm going to put the DTO class inside the model package, and I'll call it employee DTO. And it's going to be mostly like the employee class. So we'll have the ID, we'll have first name, last name, address, but instead of supervisor, I'm going to just use supervisor ID. And let's generate the getters and setters. And let's also create a constructor that can construct a DTO from an employee object. So that means the ID will be the employee ID first name will be employee first name, and the last name will be employee last name, and the address will be employee address, and the supervisor ID will be supervisor. Now that depends on whether the supervisor is null or not. If it's null, then the ID should be null. If it's not, then it should be supervisor get ID, something like that. Okay, so this is our employee DTO class. As we can see, we can basically make it in any way we want, and we simply need to convert an employee object to an employee DTO object. Here we do it inside the constructor, and here, instead of returning employee, we are going to return employee DTO, and without having any better way to do this, we'll have to do it like this. So we'll create a list of DTOs. And then we'll say for each employee in find all, we'll add new employee DTO, and then we'll return the list of employee DTOs. And we can return it as a list of iterable or list, but I guess iterable is fine. Let's run this. And then let's refresh. And now the result looks reasonable. Instead of having supervisors and supervisors and supervisors, we now have John doesn't have an employee supervisor, and Jim's supervisor is John, and Tom's supervisor is Jim. Okay, so then let's move on to the next operation or the next endpoint, get an employee. The basic implementation should be fairly straightforward. So let's do that. As we discussed earlier, the URL pattern would be employees with an ID, and it's going to return an employee DTO. And we'll call the method get employee. It's an ID, and we'll say employee repo find by ID, and this thing returns are optional, so we'll say or else no, it's no, something like that. But this is an employee object. We need to return employee DTO, so we'll put it inside the constructor. Okay, so the basic implementation is just that, and we can try one. Oh, did I? Oh, we forgot pass variable, I think. Yeah, we need to get this one from the pass, and it's the same deal as in application. I just need the pass variable annotation. Okay, so now we got John, and so as I said, the basic implementation is pretty straightforward. With that being said, here is a potential problem. Suppose the user enters an ID that doesn't exist. Now we get a 500 error. And that, of course, is because this one is null. And if it's null, then this one is null. And null, of course, cannot do get ID or get first name. So a simple fix would be checking checking whether the employee is null. If it's not, if it's null, then return a null. The problem is returning a null is sometimes not a good solution because there is a difference between having a null value, which is still a value, and something just doesn't exist at all. For REST API, since the result status should be reflected in the response status, the proper way is to return a for status. However, if we look at the method here, we can see that it returns an employee DTO. So how can we return a for status when the return type is an employee DTO? Well, that takes us to error handling. Generally speaking, there are two types of errors. Errors that we know that will happen, for example, login errors. We know that sometimes users will enter their password wrong, and it's not a surprise. So that's an error that we expect to happen. Another type of error would be somebody filling up a web form and some required fields are missing, and that's another expected error. So for this type of expected errors, we need to program it in our code to inform the client to fix the error. And then there are certain errors that are unexpected, like a database exception. Just yesterday or the day before yesterday, we had a server error and the server disk ran out of space, so all the database operations failed, and that's unexpected error. And we usually need to log those errors for analysis and correction later. And in a web application, we can usually redirect the user to a error page or something like that. But in a web API, there's no human user involved, so there's no error page for people to read or no redirect. What we need is to send back a status code so the client application can use the status code to figure out what's wrong. And in addition to status code, often we also want to send back some error message as well. Now in Spring, all those errors are actually handled with exceptions. So that's why, although the return type is an employee DTO, we can still send back an error because exception is something raised separately, different from the return value. So for the expected errors, I would recommend raising a response status exception. So this is an exception provided by Spring Framework, and it allows us to specify a status code and error message. So for example, here we can do something like this. We'll say employee is find by ID or else. Now, if E is null, and we throw a new, what that exception is called, response status exception. And this one let us to specify a status. And we'll use the not found status, and it also allows us to specify an error message. We can say employee not found, something like that. And let's import this one. And, and then otherwise we'll return an employee DTO. So if we try this again, we can see that this time we get a status 404, employee not found. So this is a simple but mostly good way to handle expected errors. Now, for the exceptions that are kind of unexpected, but we want to catch and log, Spring provides a mechanism called controller advice. Now, we won't cover this here, though, because it requires some knowledge about the so-called aspect-oriented programming. But if you do a more complex project that require you to catch certain exceptions, then look into using controller advice, which allows you to separate your exception handling code from your application code. And then, of course, there's always the default exception handler in Spring Boot that catches any exception that's not handled by the application code. And this exception handler will send back a 500 error response, like what we saw earlier. Now, let's implement the next endpoint, which is adding an employee. Let me stop this one. Okay, so for adding an employee, remember the endpoint design conventions. We will use a post request, and we will post to employees. And what we return, let's say we return the ID of the newly added employee. So we will add an employee, and that employee is going to come in as an employee DTO. Yes. Let's call it input. Okay. And now we can use employee repo to save a new employee, but we need to convert that DTO into an employee first. So let's do that here. So let's create a method called toEmployee, and this one will create a new employee, and the employee will have the ID, the first name, the last name, the address, yeah. And now the supervisor of employee is an employee object, and here we have employee supervisor ID. So we'll say supervisor. Let's create a new employee object here, and then we'll say the supervisor's ID will be supervisor ID, something like that. Okay, so we'll see if this thing works. All right. Okay, so then what we can do is we can say employee repo is save input to employee, and then we're going to return the ID of the newly saved employee. Okay, something like this. Now, The code is something like this, but how do we test this? Now, when we test a web application, we can use a browser. A browser, can show the result of a GET request, and we can create a form to do POST requests and so on. But when we test web APIs, a browser is not flexible enough because a browser cannot easily create request other than GET and POST. If we want to create a patch request, it's very difficult to do with a browser, and also a browser doesn't show the response in a way that's easy to look at in terms of headers, status code, and so on, unless we go into developer tools in a browser. Anyway, the most commonly used tool to test web API is this tool called Postman. So it's a free download, and it has versions for all kinds of different platforms. I already downloaded Postman here. This is what it looks like when we open it up. There's a signing step. I already signed it in, so it shows my previous used test requests and so on. So let's say we want to use this to test our API. So the simple way to do it is, let's see, we want to test the employees endpoint using a GET request, and we just say send. I guess it's not running right now. Okay, so it's a form for, oh, okay, because it should be API/employees. Okay, so as we can see, it's pretty easy to use. It's kind of like a browser, but for web APIs. We enter the URL, choose request method, and we can customize headers and body, and then send. And the response is shown here, the response body, and also the response status is shown here. So if we do like employees 1, it shows this. Now, let's say we want to test the add employee part. So it's going to be a post request, and the URL is going to be employees. Now, we need to pass an object in the body of the request. So we go to body, and let's select raw, and let's select JSON. So let's put a JSON object there. For a new employee, we'll say first name is Steve, last name is Sung, and the address is 123 Lane Street. And what else do we need? DTO. We need ID, first name, last name, address, supervisor ID. So a new employee, of course, doesn't have an ID. So supervisor ID. So let's say Steve is supervised by John. So supervising either by ID1. And note that if we look at the headers, after we type in the body and select JSON, it automatically includes a content type header which says application JSON, which tells the server-side API that the request contains the body of the request contains a JSON object. Okay, so we consent, and we get internal server error that says, what does it say? Cannot instantiate. Cannot invoke get ID because E is null. Let's see if it's saved into the employee. Okay, so the save failed. That's why it's no. Let's see. So we convert the input into an employee, and we say save, and what did I do? Why is calling this method? So we have an employee DTO, and it converts that into an employee. So it should be new employee, the DTOs. Oh, request body. So it's kind of the same error as this one. We need to tell Spring where this input comes from, and yeah, I forgot this one. Now let's save and try again. And send. Okay, so what's happening this time? Cannot construct instance of DTO. No creators like default constructor. Why does it need a default constructor? Oh, okay. So we need a default constructor so that the framework can create an employee DTO and then set the properties. Employee DTO. Okay, so this should do it, hopefully. Okay, so we get a new employee ID, and then yes, so we can see that Steve gets inserted, and with the proper supervisor ID. So that's good. Moral of the story is don't forget request body and use Postman, and also if we look at the response, it says 200 OK, which is a good enough response. But if we want to do a little bit better than that, there's actually a HTTP status indicating something that is already created. So we can, instead of using the 200 response, we can say for this one, we want a response status, which is created. And if we do this again, we just created another Steve, I guess, right? And but this time, notice that the response status is 201 created, which is a better response status code for creating something successfully. Okay, so moving on. Now let's talk about the update operation. As we discussed earlier, we can either do a full object update using put, or update only part of a object using patch. If we use put, the code is not too different from the add employee code, so I'll skip that. You can do it as an exercise. For the partial update, there are actually two ways to do it. One approach is to update individual property by having an endpoint like this. So if we want to update just the name of the employee, we can use a put and then put the new name to this URL. The problem, of course, is that we will then need an endpoint for every single property. That's fairly tedious to do. Another approach is to send only the properties to be updated in a patch request and then bind them to a map with string keys and object values. So in other words, instead of binding the input to an employee DTO, we're going to bind it to a map, and then we iterate through the map and update the fields that we need to update. So let's quickly implement that. So we are going to do a patch mapping. And it's going to be employees with an ID. It's not path, it's patch. And this one, what do we return for this one? We'll just return a void, which will become a tool for no content response if it's successful. So we'll return void and we'll say update employee, and don't forget pass variable ID. And then don't forget request body, and the request body is going to be a map of string and object. We'll call it update. Let's import. Okay, so the first thing we do, of course, we'll need to get the employee by ID. So we'll do something like this. So we'll say find by ID. If it's null, then throw a 4 exception. And then we'll say for each key in update key set, And then we'll do a switch. We'll say if its first name we'll do e dot set first name update get key and then break. Oh, we need to cast it to string, something like that. And then let's say last name and address. This one would be set last name and then set address, something like that. And then after all that, we'll do a save. Employee repo save. Okay, so let's see if it works. And let's do a patch. And let's patch which one? Let's say we want to patch 202 Steve. And the body is going to be JSON, and let's say first name should be Jack, and the last name should be, I don't know, Johnson. Okay, so it's a patch. Let's send. No, it's not running. Let's run it. Okay, we got a 200 OK back, no response body, so that's good. And if we refresh here, it has changed to Jack Johnson. Okay, so I guess it doesn't automatically return 204. So that means if we want, we can do this, and the status will be no content or something. No content. Yes. Okay. All right. So that's how we implement update. And lastly, let's talk about delete. Delete is not difficult to implement, so I'm going to skip the coding part. Instead, let's just talk about what's hard delete and what's a soft delete. So hard delete basically actually deletes data from the database, and obviously once you do that, it's difficult to recover data. But the good thing, of course, is that the data is actually deleted, so you'll save disk space, and the resources become cleaner. But it may have some unintended consequences. For example, cascading delete. When you delete a project, maybe it cascade delete to employee, so you also unintentionally deleted an employee who's participating in the project, or you may end up with so-called orphan data, and so on. So that's the pros and cons of a hard delete. And then there's the so-called soft delete. Basically, instead of actually deleting something, you'll just set a deleted flag, which means, for example, in our employee class, we will have another field called deleted, which by default is false, meaning it's not deleted. And once we want to delete an employee, we just set that field to true. So in other words, it's basically an update. Generally speaking, a soft delete is faster and safer, and if you want to recover data, it's easier. The only thing is that other operations need to be aware of this flag. For example, if we implement soft delete here, then when we do, for example, get employees, then we cannot simply say find all. We have to say find by not deleted or something like that. So only return the employees whose deleted flag is false. So which one to choose, it depends. But either way, it's not difficult to implement. So, okay, this is the end of this video. Thank you, and see you in the next one.